Hi everyone, welcome to a new video. Today we'll be looking at a new and easy method to solve quadratic equation. This method was publicized by Professor Po-Shen Loh, Carnegie Mellon University. So in this video, I'll first describe the logic behind the method, and then I'll go through a few examples to illustrate it. So stick around. So first, let's look at the logic behind this method. Let's first consider a quadratic equation. So notice here that a is equal to 1. We'll come back to the case when a is not equal to 1, but we're starting with the simple case when a is equal to 1. Assume that we are able to factorize this equation. In other words, we are able to write this in the form of product of two vectors. For example, x minus r1 times x minus r2 equals to 0. Now we know that if you are multiplying two things, one of them has to be 0. So what this means is that either x minus r1 equals to 0 or x minus r2 equal to 0. And this in turn means that either x is equal to r1 or x is equal to r2. So essentially this r1 and r2 are the solution to our equation if we are able to factorize this quadratic equation. Now let's do one thing here. Let's take this one and we expand it. So what we'll have here is x times x, that gives you x squared, and then x times r2. So this will give us minus r2x. And then we'll take r1 times x, so there's a negative here, so again we'll get r1 x, and then we'll have minus r1 times minus r2, that will give us r1 times r2 equal to 0. We can see that x here is a common factor, so we can group these. So what we'll have here is the minus r1 plus r2 x r1 times r2 equal to 0. Again, this is based on our assumption that we are able to factorize this quadratic equation. What we'll do next is to compare the original form. So we are comparing the original form with this form. And we will notice that the coefficient for x squared in both forms is equal to 1. And the other thing that we can see is the coefficient of x. So we can see here that the coefficient of x is equal to b from the first equation, and it's equal to minus r1 plus r2. Or in other words, we can say that r1 plus r2 is equal to minus b. Now this gives us the sum of the two solutions to our equation. Remember, our solution is r1 and r2. So this is giving us the sum. If we draw the real line and we say that this is r1 and this is r2, so this is their sum. I can get their average, which will be the midpoint between them. So this is the midpoint here, which is r1 plus r2 divided by 2. From what we get here, I can easily get this midpoint. You can see that r1 plus r2 is simply equal to minus b over 2. This is midpoint. If it is the midpoint, what that means is that the distance from this midpoint to r2 is the same as the distance from r1 to the midpoint. If we assume that this is u, this distance is u, then this also must be u. And the insight here is that I can write r2 equal to the midpoint plus u, and r1 the midpoint minus u. So this is one thing that we learn from comparing. Another thing is the last term here is c, and the last term here is r1 times r2. In other words, the product is equal to c. So this is the product of the two. It's equal to c. And this product, we can write it in terms of midpoint times u and midpoint minus c. If you look at this equation, this one here, we can see that we know c. This will be given in the original equation. Midpoint, we can calculate it easily. it's just minus b over 2. So the only unknown in this equation is u. And then once we find u, we can easily find the roots. Remember, the roots will be mid plus u and mid minus u. So this is the logic behind this method. So now let me show you the step that you need to follow if you want to apply this method. All this detail might be confusing, but the method, when you are applying, it's very simple. So the steps will be as follows. Again, we start with equation of this form where the coefficient here is 1, and we make sure that it's actually in the standard form. Okay, so if you have more than one term with x, you need to group them. Similarly, if you have anything on the right-hand side other than 0, you need to move it to the left-hand side. And then the calculation goes as follows. First, we calculate the midpoint between the two solutions. As we see in the analysis that we did, it's simply minus b divided by 2. And then we'll assume that the solution are m plus u. This is m, this is the midpoint, plus u as unknown, which is the distance between the midpoint and any of the roots. And the other one will be m minus u. And then we'll utilize what we learned also about the product. So we know that the product is c, but also based on our assumption, it's the product of these two roots, which is m squared minus u squared equal to c. And we'll solve this equation for you, and from there we'll be able to get the roots. Okay, things become more clear if we look at examples. So let's look at example. We have x squared plus 6x plus 8 equal to 0. So let's apply the method. So the midpoint is simply minus b, which is 6 here, divided by 2. So this gives us minus 3. And then we'll assume the solution will be the midpoint plus u and the midpoint minus u. The other thing that we know also is the product. The product, as we've seen, is equal to the constant term, which is 8, but also it's equal to the product of these. So it will be minus 3 plus u times minus 3 minus u. Recall that whenever you have anything a plus b times a minus b, this is simply mean a squared minus b squared. You can get to this form easily if you expand a times a, then a times minus b, and b times a and b. You will see that the terms that have a and b, have one is negative a, b, the other one will be positive a, b, cancel each other, and this is what left. So if we apply that here, we will see that you have minus 3 squared minus u squared, or 8 equal to 9 minus u squared. Then let me take you to one side and take all the numbers to one side. So this will lead to u squared equal to 9 minus 8. I took the u squared here, and I took the 8 here. And once we have this, we can see easily that u is 1. You can also take minus 1. It will not make any difference, because we know whenever you have u squared equal to 1, there are two possibilities. Either u is equal to 1 or it equal to minus 1. So any one of them will lead to the correct solution. In this case, I just took the positive. So our solution is equal to minus 3 plus 1 and minus 3 minus 1. And this will give you minus 2 and minus 4. This is the solution to the quadratic equation. If you took here minus 1, then what will happen here is that you'll get here minus 3 plus minus 1 will give you minus 4. And here we get minus 3 minus minus 1 will give you again minus 2. So you can see it doesn't matter whether you choose the positive root or the negative root. Both will lead to the same answer. Okay, let's look at another example. We have x squared minus 8x plus 9 equal to 0. So again, the midpoint is minus b, so it will be minus 8 over 2 will give us 4. And again, we assume the solutions will take the midpoint plus u and the midpoint minus u. So u is something that we don't know, but represent the distance from the midpoint to the root on either side. And the other thing we know, we have to calculate the product. The product is simply the constant term, so it's equal to 9. And the other way to calculate the product is based on our assumption. So it will be 4 plus u and 4 minus u. And this simply will lead to 9. Again, this will be 4 square minus u square, or 16 minus u square. Again, I can take the u square in one side and the numbers in one side. So what you will get, we'll take this u here and we'll take the 9 to the other side. So we'll get u square. The sign will change from negative to positive, and then you'll have 16 minus 9, and this will give you 7. So again, we have two possibilities for the root, positive and negative. I can take any one of them. Let's take the positive. So here u will be the square root of 7. And then the solution will be simply, so the solution for the roots for the quadratic equation will be midpoint plus the u that we find, or 4 minus. These are the solution. Again, you can imagine if we're trying to factorize, it would be very difficult for us to come up with these numbers if we're trying to factorize this one. But this one, we get it directly. Another example. Similarly, so midpoint will be minus 4 by 2 minus 2. And then again, assume the solution. Midpoint plus u and midpoint minus u. We know again the product is the constant, so it will equal to c. And the product, again, we can get it by multiplying these. So it will be minus 2 plus u times minus 2 minus u. And this gives us 6 equal to minus 2 square minus u square, or 4 minus u square. I can again move the u square to one side and the numbers to other side. So the u will go to this side and the number go there. So we'll get u square equal to 4 minus 6. And this gives us minus 2. Now looking at this, we have a negative number and we are trying to find what is the square root of a negative number. What's the number when we square it, we get a negative. We know that there is no real solution. No real solution. So if you are looking for a real solution, that's it. There is no real solution to this one. We cannot find a number that when we square it will give us negative. However, if you are familiar with complex number, we can solve this. So this will be u, the square root of minus 1 times 2. Remember, minus 2, we can write it as minus 1 times 2. And this will be square root minus 1 times the square root of 2. We know this is defined as I, if you are familiar with complex numbers. So this will be I square root of 2. So the solution will be the midpoint, which is minus 2, plus u, which is I square root of 2, or minus 2 minus I square root of 2. So you can see even this method can use it even to find complex root. Or if you don't want complex roots, you can also conclude that there will be no real solution. Okay, so in all of these examples, we were looking at x squared with a coefficient equal to 1. So what happened if the coefficient of x squared is not really 1? How should we handle that case? So let's take example 2x squared minus 10x plus 5. So this shows you a case where the leading coefficient of this one is not 1. And it's actually, the trick is very simple. You just divide by whatever a is here. If it is 2, you divide everything by 2. If it is 4, you divide by 4. Here, if we divide this by 2, we will get x squared minus 5x plus 6 equal to 0. And it doesn't matter, even if you get some fraction, case of if this 10 was 5, for example, what you'll get is 5 over 2. The method still will work out. So don't worry, just divide by 2 and you follow the same steps. So here, the midpoint will be minus p over 2. So this will be minus 5 over 2 or 5 over 2. And then we assume the solution to be midpoint plus u, or the midpoint 5 over 2 minus u. The other thing we know is the product. So the product is equal to the c term, sorry, this one, 6. So it will be 6, and we can also get it by multiplying 5 and 5 over 2 minus u. This would give us 6, 5 over 2 squared minus u squared. And this one is equal to 25 over 4 minus u squared. Again, we can move the u squared to one side and the numbers to the other side. So if I bring u squared to this side, and then we can take 4 as a common, 25 minus 6 times 4, 24. So this is 1 over 4. And again, u will be 1 over 2. So then the solution will be our midpoint 5 over 2 plus 1/2, or 5 over 2 minus 1/2. So this is 5 plus 1. 6 divided by 2 give you 3. And here 5 minus 1, 4 divided by 2 give you 2. So these are the solution to our equation. You can again verify this by substituting on the quadratic equation itself. So we see in this method you can apply it to any case. Just be careful that a should be 1. If it is not 1, you just divide by whatever the value of a and just carry out the normal calculation that we see in here in these examples. Finally, if you find this video useful, please give it a like and don't forget to subscribe to the channel and turn the notification on so that you get notified about new content. Thank you for watching.